Hello everyone, welcome back to the map of mathematics. In this video, we are going to solve this nice math Olympiad geometric problem. And here we have a nice trapezoid A, B, C and D inscribed a right triangle E, D and C. And here we need to find the area of this right triangle EDC. If we have given the sides of the trapezoids are, we have the side length of AD is 95 and the side length of BC is 57, and you focus on first you focus on this triangle EDC, and you see that we have the length of these two sides are equal, and you know that any triangle in which the length of two sides are equal is known as the isosceles triangle. So here first you see that our right triangle EDC is isosceles triangle. Okay, so if it is isosceles triangle, it means that we have the length of the side ED equals to length of the side EC. And now in the next step, you focus on the right triangle. So here we have, this is our step 2 and this is our step number 1. So in step 2, you focus on the triangle E, A and D. So here you have, this is the triangle E, A and D, in which we have the one angle is 90 degree and we don't know about the other two angles. So you know about the right triangle, the sum of all three angles of a triangle equals to 90 degree, equals to 180 degree. Okay, so if you have this angle is 90, it means that the sum of these two angles are 90 degree. So that it means that here we introduce the complementary angles. So here we introduce alpha and beta be the two complementary angles, and you very well know about the complementary angle are the complementary angles. So here we denote this angle by alpha and this angle by beta, and you know that the angle at the vertex A is 90 degree. So we have the sum of these three angles are 180 degrees. So the sum of alpha plus beta equals to 90 degrees. So it means that alpha and beta are the complementary angles, because the definition of complementary angle is that any two angles whose sum is 90 is called the complementary angles. So we have alpha and beta be the complementary angles. And now in the next step, you see here similarly in the right triangle E, B and C, and in the same case we have this angle is a right angle or 90 degree angle. So we call this angle is alpha and this angle is beta. So it means that here again we have alpha and beta are the complementary angles. So now here you focus on both triangles, triangle EAD and the right triangle EB and C. So here in the diagram we have these two triangles are the similar triangle or congruent triangle. So we write it here, EAD is congruent to EBC because of angle side angle postulate. In this diagram you see here we have angle side angle postulate is satisfied on both of these triangles, so that here we know that if two triangles are congruent, if these two triangles are congruent, it means that all these angles and all these sides are congruent to each other. So we have, if this side is 95, this side length is 95, and this side length is 57, so we have this side length will becomes 57 and this side length will becomes 95. So that now we focus on this diagram EAD, and we find the length of this hypotenuse ED. So that now we focus on the diagram, and we see here the right triangle EA and D, and now we use here the nice Pythagorean theorem on the right triangle EA and D. So this is the our right triangle EA and D, and by Pythagorean theorem we have its hypotenuse. So that here we use the Pythagorean theorem on the right triangle EAD, and we find the third side length, and after that we move towards the area of the required triangle. So that now we know about the Pythagorean theorem. It is about hypotenuse square equals to base square plus perpendicular square. So this is the formula of Pythagorean theorem. And if we focus on this right triangle, and we know that the side opposite to the right angle is known as the hypotenuse, and the side which join these two angles is known as its base, or this side is called perpendicular. So now we substitute all these three values in this formula, and we get here, because here we find the value of hypotenuse, so we write it here, and our base is 95 square, and the value of perpendicular is 57 square. And now we simplify these terms, and we first write this 95 as 19 times of 5 and its whole square, plus we write 57 as 19 times of 3 and its whole square. And now we simplify the terms, and we write it as 19 square be the common term, so we take it common, and you get 5 square plus 3 square. So here we have 5 square becomes 25, and 3 square will becomes 9, and finally we got here 19 square times of 34 equals to hypotenuse square. So that here we take a square root on both of the sides, and we get the value of hypotenuse is 19 times of 34 square root. So this is the value of hypotenuse. And when we put the value of hypotenuse here, so you see that this hypotenuse and this hypotenuse are the same value, and this value is 19 times of square root of 34. So that now we move towards the to find the area of this right triangle, and we have the side or we know that the formula of area of triangle is written as in this form. So here we have the area of triangle equals to half times of base multiplied by height. So we denote height by h, and in this question we have the base is our base is denoted by 19 times of square root of 34. So this is the our heights, and our base is denoted by 19 times of square root of 34, because if you focus on this triangle E, C and D, we have, because this triangle is isosceles triangle, so we have these two values are same, and this value is the base and this value is the height of this triangle. So that we put these two values here, and you get half time of 19 into 34 square root into 19 into 34 square root, and when you simplify all these terms, then finally you get the value of area is 6137 square units. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.